In video number 54 I used this small boost converter which takes in 5 volts and it boosts up to plus 12 volts, but you also get minus 12 volts, so that makes it ideal for driving op-amp circuits where you need a split rail power supply. But now I've just received another similar module, so that one here. If we take this out, so this is a little bit smaller, and similarly it takes in 5 volts and you get plus 12 volts, minus 12 volts as the output. This one is not so powerful as the other one. I think the maximum from the data sheet was 50 milliamps, so you get 50, I think from memory it was 50 milliamps on the positive rail and about 40 on the negative rail. So it's not nearly as generally useful as the other one, but you know, 50 milliamps is enough to drive a couple of op amps, and it could be useful in some situations. So I'll fire it up and we'll have a look. There's a couple of wires attached to that now, so I'm going to put in 5 volts and we can measure the output on the split rail. I'm going to connect up the 5 volt power supply, so that one. Okay, so it's drawing a small amount of current now, about half a milliamp I think. Let's put that on the ground pin there. I got 12.5 volts on the plus V side and minus 12.06, a little less on the negative side. And just to check, I think the ground, I think it's the same ground in both cases, but we'll double check. Whoops. Yeah, minus 12, plus 12, so it's the same ground. So again, like the last module that I tested, that's a very useful configuration. That was interesting. I just went to solder some header pins on here, but it doesn't have the standard pitch for header pins. It's a little bit wide, so I'm going to have to put individual pins in there, I think. Okay, so I've got the headers in place, and I think the wiring is the same for the old module as for the new. Yes, it is. So I'll just swap over these wires. Okay, that should be correct for my op-amp circuit. Just check the voltages. So here to ground, 12 volts, and then I want the orange wire, and that's the minus 12 volts. So we've got the correct power on the chip, and so now we need to put a signal in. So here we are, we've got the 1 kilohertz signal which is actually being generated out of the scope here. So I've got 1 kilohertz output. So the 1 kilohertz output is going into the op-amp via the probe over here. So we can see we've got 5 volts per division, so that's a 5 volt peak to peak square wave as the input to the amp. Now so we should be amplifying the signal. I'll just connect this to the amp so you can hear the 1 kilohertz. So that sounds pretty good actually, it's not distorted at all. And if we put the probe on the other channel of the oscilloscope to get the output. Okay, so these are both on 5 volts per division, so you can see the top, the input is 5 volts, and the bottom, the output, is 10 volts peak to peak. So if you watched the earlier video, you would have seen that the op amp I set up in a non-inverting configuration and with a gain of 2. So the only visible distortion is this little kind of squiggling at along the top of the square wave, and that's obviously a very high frequency, and that probably does come from the boost converter. But that's pretty good for its low cost. That's quite a useful board to connect to an audio circuit. So by the way, I switched the input actually, so I'm now powering it from this lithium battery, so lithium ion battery, so it's running off 3.7 volts. So like the other one, this boost converter can run off 3.7 volts, doesn't necessarily need to have 5 volts, so that makes it quite useful for portable equipment. Well, thanks very much for watching, hope you enjoyed it. See you in the next video.